Welcome to the video. This is 5.12 kinematics. So deals about velocity, acceleration and displacement. Before we starting the video, so we should learn a basic things. What is that? We have displacement. Displacement is denoted by S. If I do the derivative of the displacement, ds upon dt, it's going to giving me the velocity, and which is nothing but what? V. And if I do the further derivative of velocity dv by dt, it's going to give me the acceleration. So displacement to velocity, velocity to acceleration is nothing but what? Differentiation. Now if at all you want to go backwards, acceleration to velocity, you have to do the integration. Acceleration is a ADT. Integration of acceleration is going to be nothing but what? Velocity. Similarly, from velocity to displacement means integral of velocity is going to give me the displacement. So if at all you want to go backwards, it is integration. So displacement to velocity and velocity to acceleration is the differentiation, and in the backwards it's going to be the what it says. So let me write it out over here. This is going to be integration. So based upon that, we shall start it out. Question number 1. The displacement is given. Calculate the velocity in terms of t. So velocity is going to be ds upon dt, which is nothing but what? 12 minus 3t square. Now after 1 second, so velocity after 1 second for part 2, t equals to 1, so v will be equals to 12 minus 3, which is 9 meters per second. Don't forget to use the units. Part B, calculate the acceleration. So acceleration equals to nothing but what? dv upon dt, which is nothing but what? Negative 60. What is the acceleration at t equals to 1? So a equals to minus 6 meter per second square. Part C, find the value of the time t in the following instances when the velocity is minus 15. So 12 minus 3t square equals to negative 15, 3t square equals to 27, t square equals to 9, t equals to 3 seconds. When the car is stationary, for stationary, velocity equals to 0. 3t square minus 12 equals to 0, t square equals to 4, t equals to 2 seconds. When the car passes through point A. Car passes through point A means it has come back to its original position. When it comes back to its original position means displacement should be equals to 0. 12t minus t cube equals to 0. So t common, 12 minus t square should be equals to 0. So either t equals to 0 or t square equals to 12. So t equals to square root of 12, that is 2 root 2 seconds. That's going to be the answer. So at the beginning it is at 0, and again after 2 root 2 seconds it is at 0. Now coming to question number 2, the acceleration a of a car t seconds after the leaving is given by, find the velocity. So velocity is integral of acceleration, so which is going to be minus 3t square plus c. Given that the initial velocity is 12, so if t equals to 0, v equals to 12. So 12 equals to minus 3t square t0 square plus c. So what is the value of c? C is 12. So what will be the formula of the velocity? Minus 3t square plus 12. Part B, displacement in terms of t. So s equals to integral of v dt. So what is that? S is going to be minus t cube plus 12t plus c. So now again at t equals to 0, the initial displacement is 0. S equals to 0. So 0 plus c equals to 0. So c equals to 0. So what is the formula for the displacement? Minus t cube plus 12t. Next, the maximum positive displacement. So maximum displacement. Maximum displacement means ds upon dt should be equals to 0 because velocity is 0. So 3t square minus 12 should be equals to 0. So t square equals to 4, t equals to 2 seconds. So in that case, what will be the value of s? S will be minus 2 cube plus 12 times of 2, which is 16 meters. The time intervals in which the velocity is positive. Is asking the velocity should be positive. So v equals to minus 3t square plus 12 is greater than 0. So 12 is greater than 3t square. So t square is less than 4. So t lies between 0 to 2. We will be getting it at plus or minus 2, but time cannot be negative. So t lies between 0 to 2. Then the time intervals in which the displacement is positive. So displacement S equals to minus t cube plus 12t is greater than 0. So again, what is the case? T common, 12 minus t square is greater than 0. 12 minus t square is greater than 0. T square is less than 12. So t lies between again 0 and square root of 12. Square root of 12 is 2 root 2. That's going to be the answer. Now, question number 3. The velocity v of a car t seconds after leaving a fixed point A is given by find the acceleration in terms of t. So, acceleration equals to dv upon dt, which is minus 60. Calculate the displacement given that the initial displacement is 0. So, s equals to integral of v dt, which is minus t cube plus 12t plus c. But it has been given that t equals to 0, s equals to 0. So what does it become? 0 plus c equals to 0 implies c equals to 0. So therefore s equals to minus t cube plus 12t. The car is stationary at t equals to a. Find the value of a. Stationary. What is the meaning of stationary? Stationary means velocity equals to 0. 3t square minus 12 equals to 0. T square equals to 4. T equals to 2 seconds. Find after 3 seconds the displacement and the distance traveled. So displacement after 3 seconds. So s equals to 3 cube minus 12 times 3, which is minus 9 meters. Now for the distance traveled, not displacement, for the distance what you are supposed to do it is, it's 0 to 3 absolute value of v dt, which is 0 to 3 absolute value of 3t square minus 12 dt, which is going to be nothing but what? 23 meters. So you have to check very carefully whether it is displacement or distance. This is with GDC. If at all you don't want to do, if at all in paper 1 it does comes without the GDC, then what am I supposed to do it is, because we know that after 2 seconds the direction is changing. Because it is coming stationary after 2 seconds, then it is coming backwards in 2 seconds. So 0 to 2 seconds, then again for that 1 second it is coming backwards. So therefore what am I going to do? 0 to 2 v dt, which is 0 to 2 3t square minus 12 dt, which is going to be t cube minus 12t from 0 to 2, which is 16 meters, negative 16 meters. Then again 2 to 3 3t square minus 12 dt, which is again t cube minus 12t from 2 to 3, which gives me 7 meters. So total distance is going to be 16 meters plus 7 meters, which is going to be 23 meters. This is without GDC. Sketch the diagram of V in terms of T and shade the region area. Indicate the distance traveled after 3 seconds. So what is happening? In the first 2 seconds it is a negative area, and 2 to 3 seconds it is positive area, 12 minus 3t square. So when I do by the graphing calculator or the Desmos, I will be getting it out 12 minus 3x square graph. So for that I take the graphing calculator and do that one, 12 minus 3x square. So and the limits are from 0 to 3. Time is from 0 and 3. I'm using the calculator. This was -2 and this is nothing but what, 2. So this is 0 to 2 and 2 to 3. That is the region area under the graph. Question number 4. The distance s meters of a car t seconds after leaving a fixed point is given by this one. Calculate the velocity at t equals to 0. So velocity equals to ds upon dt, which is 10 minus t. So t equals to 0. So velocity will be equals to 10 meters per second. Then part B, the calculate the value of t when the velocity is 0. So ds upon dt should be equals to 0, means 10 minus t equals to 0, t equals to 10 seconds. Then calculate the displacement of the car when the velocity is 0. So substitute that t equals to 10 seconds. So you should be getting it out 50 meters as the answer. Question number 5. The displacement s meters at a time t seconds is given by this one. Write down the minimum value of s. So when you plot it out the graph on the GDC, s minimum you are going to get it as 6.05, or else you can write 1 comma 6.05. Find the acceleration. So ds upon dt is the velocity, which is minus 15 sine 3t plus 2t. Now again acceleration will be the derivative of that one, d square s upon dt square, which is minus 45 sine 3t plus 2. Find value of t when the acceleration occurs maximum. So when it is maximum occurs, this is cosine 3t. So whenever the maximum occurs, when this cosine 3t is -1. So minus 45 times -1 plus 2. So that, what is that? It should be -1. That's going to be the maximum value. So cosine 3t should be equals to -1. So 3t should be equals to pi. So t equals to pi upon 3, because cos 180 is -1. So 3t equals to pi, t equals to pi upon 3. Question number 6. The velocity v in meters per second of a particle moving in a straight line is given by this one. Find the acceleration at t equals to 1. So acceleration equals to dv upon dt, which is 3e to the power of 3t minus 2. And acceleration at 1 is plug in 3e, which is 8.15. Part B, at what value of t does the particle have a velocity? 22.3. E power 3t minus 2 equals to 22.3. Solve it out by calculator, 1.70. Find the distance traveled in the first second. So s equals to integral of v dt from 0 to 1. So integral of 0 to 1 e power 3t minus 2 dt, which is e power 3t minus 2 upon 3 from 0 to 1. So when you do by calculator, you will be getting that answer 0.861. Question number 7. The velocity v meters per second of a moving object at a time t seconds is given by this one. When t equals to 2, the displacement is 8 meters. Find the expression for displacement. So s equals to t power 4 minus t square plus c. So 8 equals to 2 power 4 minus 2 square plus c. This give me c value as -4. So s equals to t power 4 minus t square minus 4. Find the acceleration after 1 second. So a equals to 12t square minus 2. At t equals to 1, plug in a equals to 10 meter per second square. Question number 8. The velocity v in meters per second of a moving body is given by this one. When t equals to 0.5, the displacement of the body is 10 meters. Find the displacement when t equals to 1. So s equals to integral v dt, which is 1 upon 2 e power 2t minus 1 plus c. Now at t equal to 0.5, so 10 equals to 1 upon 2, t equals to 0.5. 10 equals to 1 upon 2 plus c, which gives me c value as 9.5. So what is the formula for S? I'll be getting 1 upon 2 e power 2t minus 1, 2t minus 1 plus 9.5. Now plug in t equals to 1. So S equals to 1 upon 2e plus 9.5. You can leave it there, or you can write it as 10.9 in 3 significant figures. Question number 9. The velocity of a particle at a time t is given. The displacement of the particle at time t is s. Given that s equals to 2 when t equals to 0, express s in terms of t. So s equals to minus 0.5 e power minus 2t plus 60 square integration. I did the integration and got this value. Now what am I going to do? T equals to 0, s equals to 2. So 2 equals to minus 0.5 e power 0 plus 6 times 0 plus c. This gives me c value as 2.5. So what is the formula now? S equals to minus 0.5 e power minus 2t plus 60 square plus 2.5. Question number 10. A particle moves along a straight line so that its velocity is v meters per second. V is given. T equals to 0. The displacement is 7. Find s in terms of t. So s equals to integral of 6 e power 3x plus 4 dx. So which is 2 e power 3x 3t, because it is in terms of t, 3t plus 4t plus c. Now at t equals to 0, s equals to nothing but what? 7. So 7 equals to 2 plus c, c equals to 5. So what is the formula? 2 e power 3t plus 4t plus 5. Question number 11. The velocity of a moving body at time t seconds is given by v equals to 50 minus 10t. Find the acceleration. So acceleration equals to dv upon dt, which is minus 10. Find the initial displacement. S equals to integral of v dt, which is 50t minus 5t square plus c. So 40 equals to 50 times 0 minus 5 times 0 square plus c. This gives me c value as 40. So S equals to 50t minus 5t square plus 40. Question number 12. The velocity v meter per second of an object at t seconds is given. On the grid below, sketch the graph. So by using the GDC, I am drawing it out over here between 5.1 and the second line over here, and this point and this point. So I'm joining the curve over here approximately in this shape. This should be the shape of the graph. Next, write down the expression for t. So distance is 0 to 9 v dt, which is 0 to 9 15 root t minus 3t dt. Then part 2, calculate this value 148.5 meters or 149 meters in 3 significant figures. Question number 13. The acceleration of a particle in t seconds is given by this much. The particle is at rest when t equals to 1. Find the velocity of particle when t equals to 5. Velocity is integral of this one, 1 upon t plus 3 sine 2t dt. So which is ln t minus 3 upon 2 cos 2t plus c. Now substituting the point 1 comma 0. So what do I get it out? 0 equals to ln 1 minus 3 upon 2 cos 2 plus c. This gives me c value as minus 0.624. So what is the formula for the velocity? Now I get it out. Ln t minus 3 upon 2 cos 2t minus 0.624. Now plug in t equals to 5. So we will be getting it out. V at 5 will be equals to 2.24. Question number 14. The following diagram shows the graph of displacement, velocity, and acceleration of a moving object. Complete the following table by noting which graph of A, B, or C corresponding to the each function. So which is displacement, which is velocity, and which is acceleration. So for graph A, you can see that this is a negative slope, this is zero slope, and this is a positive slope. So this is going to be the minimum point for graph A. So at the minimum points, its derivative of the graph A should be equals to 0. So it is over here. It is A. So derivative of A is represented by B. Derivative of A is represented by B. So again you can see it out over here, another position. This is positive slope, this is 0, and this is negative slope. So that is the maximum point, and it is again 0 over here. That's going to be the maximum point. So derivative at that graph A will be equals to 0. So that's going to be the maximum position, and again it satisfies this condition. So A and C are related to each other. So A should be the displacement and velocity should be C. Velocity should be C because derivative of the graph A is giving me the graph C value. So therefore it is velocity is C and A is going to be the displacement. What about the acceleration? Now you can see that 0 to 1, in 0 to 1 part, where I do it out by different color. Now B, obviously the graph B will become the acceleration graph. The leftover graph is going to be the acceleration. You can see that derivative of C is going to be the graph B. So this is not B, this is C. Derivative of graph A is C. So therefore A is going to be the displacement and C is going to be the velocity. And again you can see that derivative of C, if I see the maximum point of C is over here and it is 0 for this one. So derivative of C is B. So derivative of A is C. So if I do this practice over there, this should be displacement. So this should be the velocity. And if this is velocity, this is going to be the acceleration. So derivative of A is going to be C and derivative of C is going to be B. So therefore A is the displacement, B is the acceleration, and C is the velocity. Write down the value of T when the velocity is greatest. We can see the velocity is greatest at T equals to 3 seconds. Question number 15. A particles move with a velocity v meter per second given by v equals to 25 minus 4t square. The displacement s is 10 when t equals to 3. Find an expression for s equals to t. So s equals to 25t minus 4 upon 3t cube plus c. Now s equals to 10, t equals to 3. So x equals to 10, t equals to 3. So 10 equals to 25 times 3 minus 4 upon 3, 3 cube plus c. This gives me c value as negative 29. So what is the value of s now? 25t minus 4 upon 3t cube minus 29. Find t when s reaches maximum value. S is maximum means v equals to ds upon dt should be equals to 0. 25 minus 4t square equals to 0. T square equals to 25 by 4. T equals to 5 upon 2. Then the particle has a positive displacement. Find the values of m and n. So 25t minus 4 by 3t cube minus 29 is greater than 0. Use the GDC. You should be getting that m value as 1.27 and n value as 3.55. Question number 16. Displacement is given. Find the velocity. So s equals to 50t minus 10t square plus 1000. So ds upon dt is going to be the velocity, which is 50 minus 20t. Find the maximum displacement. For the maximum displacement, velocity should be equals to 0. 50 minus 20t equals to 0, so t equals to 5 by 2. Plug in t equals to 5 by 2, you will be getting it out. T equals to 5 by 2. The distance is equals to 50 times 5 by 2 minus 10 times 5 by 2 whole square plus 1000. Simplify that, you should be getting it out 1062.5 meters. Part C, find the acceleration. Acceleration is going to be again derivative of this one, which is minus 20 meter per second square. Question number 17. An astronaut on the moon throws a ball vertically upwards. The height s meters of the ball after t seconds is given. If the ball reaches a maximum height at t equals to 25, find the value of a. So s equals to 40t plus 0.5 a t square. So ds upon dt should be equals to 0. So at plus 40 equals to 0. A equals to negative 40 upon t. Negative 40 upon t is 25, which is minus 1.6. Because units are not given, no need to write units. Question number 18. A particle moves with a velocity this much, then when t equal to 0, s is minus 3, find the value of t when the particle is at origin. So s is equals to, first of all, integral of 3t square minus 4t plus 2 dt. So s equals to t cube minus 2t square plus 2t plus c. S of 0 equals to negative 3. So negative 3 equals to 0 plus 0 plus 0 minus c. So c equals to negative 3. So what is the formula for s? S equals to t cube minus 2t square plus 2t minus 3. Now the distance has to be 0. So t cube minus 2t square plus 2t minus 3 equals to 0. Use the GDC, you should be getting 1.81 seconds. Question number 19. The acceleration is given. If the train starts at rest at t equal to 0, the distance traveled by the train in first 80 seconds. So acceleration at t is minus 1 upon 20t plus 2. So velocity will be integral of a dt. It is going to be minus 1 upon 40t square plus 2t plus c. Velocity is 0 when time equals to 0. So substitute 0 equals to 0 plus c. So c equals to 0. So what is the formula for the velocity now? I got velocity in terms of t is minus 1 upon 40 t square plus 2t. Now velocity in the first minute, displacement in the first minute. So displacement is equal to integral of minus 1 upon 40 t square plus 2t from 0 to 60. So it becomes minus 1 upon 120 t cube plus t square from 0 to 60. Simplify that, you should be getting 1800 meters. Then question number 20. So for question number 20, so question number 20. A particle moves in a straight line with a velocity in meters per second. Velocity is given. Find the total distance traveled in the first 2 seconds of the motion. Okay. So what am I going to do that? A, displacement from 0 to 2. 0 to 2, 60 square minus 60 dt, which is 2t cube minus 3t square from 0 to 2, which is 16 minus 12, which is 4 meters. Part B, displacement in the first 2 seconds of the motion. So Part A, total distance traveled in the first 2 seconds of the motion. So I have done it on part B for what says for displacement. Now finding the distance. For calculating the distance, this is part B, part A. Distance, what am I going to do? 0 to 2, absolute value of 60 square minus 60 dt, which gives me 6 meters. If you only want to do by without calculator, what is the thing is, first 0, 1. Now it is positive over here, 0 to 1 it is negative, and 1 to 2 it is positive. So 0 to 1 you do negative 60 square minus 60 dt, and 1 to 2 it is positive 60 square minus 60 dt. So it's going to be negative of negative 1 plus 5, which is going to be 6 meters. Then explain why two results on A and B are different. So displacement is 4 meters, distance is 6 meters. So because there is a change in the direction at 2 seconds, change in direction at 1 second. Okay, so first of all it will go 1 meter backwards and it will go 5 meters forwards. 1 meter backward, 1 meter, 5 meters forward. So total distance is going to be 6, but the displacement is going to be 5 minus 1, 4. That is the reason. Question number 21. The velocity v of an object at a time t is given. Find the distance traveled between t to a. So it is going to be 0 to a e power minus t by 2 dt, which is minus 2k e power minus t by 2 from 0 to a, which is going to be minus 2k e power minus a upon 2 minus 1 meters. That's going to be the answer. Question number 22. A particle is projected along a straight line path. After t seconds, its velocity is given. Find the distance traveled in the first 2 seconds. So, the first second, 0 to 1 dt upon 2 plus t square. Use the calculator, you get 0.435. Find an expression for the acceleration. Acceleration is dv by dt, which is going to be minus 2t by 2 plus t square whole square. Question number 23. A particle moves in a straight line. Its velocity is given by this one. Find the first time it changes its direction. Changes its direction means v should be equals to 0. When it will be equal to 0? When sine t equals to 0 means sine pi equals to 0 means t equals to pi. Between the interval 0 to 2 pi, write an expression for finding the value of displacement and total distance. So displacement will be integral 0 to 2 pi e to the power of minus square root t sine t dt, which is 0.387. Distance will be 0 to 2 pi absolute value square root of t sine t dt, which is going to be 0.852. So distance and displacement difference you should be able to understand. Question number 24. A particle is moving along a straight line. Find the displacement in the first 6 seconds. So 0 to 6 t sine of pi by 3 t dt, which is going to be minus 5.73. Find the values of t for which the velocity is equals to 0. So t sine pi by 3 t equals to 0. Use the calculator, you get t equal to 0, t equals to 3 and t equals to 6. Total distance traveled. Distance traveled is going to be nothing but what? 0 to 6 absolute value t sine pi by 3 t dt, and the value will be nothing but what? When you do by calculator, 11.5 meters. Question number 25. The displacement of an oscillating body is given. Find an expression for the velocity in terms of t. So Velocity is 1 by 4 cos t by 4. And acceleration is minus 1 by 16 sine t by 4. Now part B, find the maximum displacement. Maximum displacement is 1 because sine maximum value is 1. Find the time when it passes through 0. So S should be equals to 0. When it will be 0? At 0, 4 pi and 8 pi. And D, find the two values. Velocities will be 0. Velocities will be plus 1 upon plus or minus 1 upon 4. And part E, find the time when the body changes its direction. So velocity should be equals to 0. So it should be t equals to either 2 pi, 6 pi or 10 pi. Now what is the maximum values? It is plus or minus 1 upon 16 meter per second square. Question number 26. The velocity of a car t seconds after leaving is given. Calculate the acceleration after 3 seconds. So acceleration is minus 8 e to the power of 2t. So t equals to ln 3 seconds. So t equals to ln 3. So what will be the acceleration? Minus 8 e to the power of 2 ln 3. So which is going to be minus 72 meter per second square. Part B, calculate the displacement. Displacement is integral of 16 minus 4 e to the power of 2t dt, which is 16t minus 2 e to the power of 2t plus c. Displacement equals to 0. So plug in that one. 0 equals to 16 times 0 minus 2 e to the power of 0 plus c, which gives me c value 2. So s equals to 16t minus 2e power 2t plus 2. The car is stationary at time t. Stationary means velocity equals to 0. 16 minus 4e power 2t equals to 0. So t equals to ln 2. Find the displacement and distance in ln 4 seconds. Displacement is 32 ln 2 minus 30, whereas distance is going to be 0 to ln 4, absolute value of 16 minus 4 e to the power of 2t dt. Simplify that, you should be getting it out 18 meters. That's going to be the answer. So that completes the part 1 of this video. See you in the next video for part 2.